Hi everybody, let's take a journey through a looking glass into the world of the Mystic Circuits Spectra Mirror. At its heart, the Spectra Mirror is a downsampler, but unlike any other sample rate reducer I've come across, the Spectra Mirror uses a track and hold instead of a sample and hold. With a typical sample and hold, as the sample rate, or let's call it the clock rate, gets slower, you get closer and closer to a stepped square wave, and very little, if any, of the source audio is recognizable anymore. With the track and hold, however, some portion of the audio output will be a held sample of the input signal, and the other portion will be the unaffected source audio itself. And the proportions of these is controlled by the duty cycle, or the pulse width, of the clock. A simple example of this is taking the AFG's pulse width modulation and overriding the Spectra Mirror's internal clock by patching into the clock input, and then taking the AFG's sine wave and processing that into the input, and we'll monitor directly out of the downsampler. Now, as we adjust the AFG's pulse width modulation, which is adjusting the pulse width of the clock signal, we'll hear some portion of the sine wave and some portion of the sampled sine wave. Because the clock and the sine wave are at the exact same frequency, what we hear is essentially wave shaping between the sine shape and the squared off sampled portion of the sine. This is the core of what the Spectra Mirror does, and the rest of its features are things that aid in this type of processing. There are a few different outputs. One is the output of the internal oscillator itself, which actually is a great pulse width modulation sound. The output of the downsampler that we heard before. The VCA output, which is a bipolar VCA where the morph control affects the volume. On the clockwise side, resonance has an effect. And lastly, the morph output, which is a sum of the VCA output and the input signal, which allows for some very interesting phase cancellation, as well as allowing you to blend the output of the downsampler with the unaffected input signal, which we're hearing here. So you have a lot more of a layered sound. So as we turn up, we'll get some more of that downsampler blended in. And again, clockwise, resonance plays in. All right, let's jump into some patches. Okay, this is one of my favorite ways to use the Spectra Mirror, is to sort of enhance a single oscillator and sound bigger with even more modulation. So again, we're still listening to the sine wave out of the AFG, and I'm using the sawtooth sub oscillator out of the AFG to move the morph left and right. We're listening to the VCA output, so it'll almost be like bipolar audio rate modulation. And I'm sending a 1 volt per octave CV to the Spectra Mirror and the AFG, and I've tuned the frequency on the Spectra Mirror to some kind of interval, just to basically where it sounded good. And as I turn up the bipolar morph CV, it's the AFG's sub-saw bipolar modulating the VCA on and off to give amplitude modulation. And now we'll just play with the pulse width. So again, to the left is more of the sampled signal. It's holding a sample for longer, and more to the right is passing through more of the unaffected raw signal, which would be the sine wave bipolar modulated by the saw, the sub-saw. And since they're both getting the same 1 volt per octave signal, Here's an expansion of that same patch. The AFG alien saw is going back to the input. The morph is once again being bipolar modulated by the sub saw out of the AFG. The 1 volt per octave signal of our sequencer here is going to both the Spectra Mirror and the AFG. The little addition here is some modulation of the pulse width from a cycling envelope. And the addition of the internal oscillator being patched to a Frequensteiner, which is being cut off is being modulated by another self-cycling envelope. So we're kind of layering in the Spectra Mirror almost like, well, it is a second oscillator, but it's also processing the primary oscillator. And now with the second sequencer, we could treat the Spectra Mirror kind of as its own voice. And if we stayed with musical intervals with the AFG, the processed downsampling would still be sort of in key and very musical sounding. Here's a fun example using the downsampler as a panning utility. So the way we set this up is we want to use the sampler's output as well as the morph output. We want to be in what Mystic calls high pass sampling mode, which is turn the morph all the way to the left. You want the resonance down for the most cancellation. And probably put the pulse width about 50%. You can play with it and see what you like the sound of. But what you're hearing here is as the downsampler passes the affected versus unaffected, the sample output versus the morph output are going to have different levels of phase cancellation to where one side could be phase canceled completely, and thus it sounds like it's hopping back and forth and panning. And the frequency control the panning rate. And pulse width will kind of control the balance. So 50% is going to be in the middle. What I really like is you can get this into the audio rate and get these kind of interesting stereo spread sounds. And again, with our 1 volt per octave tracking, we're listening to the AFG's alien saws into the input. My AFG is not tracking very well today. It's also possible to use a Spectra Mirror kind of as a downsampling low-pass filter / low-pass gate. We're listening to the sampler output here. I have morph all the way clockwise with some resonance, so we get a little bit of that resonant filter-like characteristic. And I just have a short envelope coming into FM1, and remember that's normalized to the frequency, the pulse width, and also the morph, but we're going to use the frequency and pulse width here. So to basically use the Spectra Mirror kind of like a VCA or a gate, we just need to modulate the pulse width from basically gating into the passing range. So if we just turn this up a little bit. And now if we were to turn the frequency down, you'll get somewhat of like a low-pass filtering effect. And if we modulate the frequency, and the envelope time, resonance. All right, I couldn't resist going extra weird here to play us out. Pretty much it's just the woggle bug and the Spectra Mirror here. The key points are the woggle bug burst out is going into the clock input of the Spectra Mirror, and the oscillator of the Spectra Mirror is going into the influence in of the woggle bug. And the ring mod output of the woggle bug is coming into the audio input of the Spectra Mirror. And we've got basically all the different random voltages controlling some aspects of the Spectra Mirror here. The stepped random voltage is coming into the pulse width, the frequency. The smooth is coming in the pulse width. The woggle is controlling the morph output, and we have some resonance here. And we're listening to the VCA, the morph control, and we're listening to the VCA output so that we can get some cancellation. We don't hear any of our input ring mod signal coming in. And then I've got some Echophone and Herb Verb to really give it some flavor. Thanks for tuning in, everybody. I hope you really enjoyed this demo of the Spectra Mirror. It's been a very, very fun module to play around with, and exceeded my expectations of what I could do with it. I hope you give it a shot and really like it. Thanks a lot.